Welcome to the final part of Unit 4. Myself, Gokul. I am working as an assistant professor in the Department of Master of Business Administration in Sri Muthukumaran Institute of Technology. In this part 4 of Unit 4, Predictive Analytics and Data Mining, today we will focus on data mining, the discovery-driven process that powers much of predictive analytics. In this session, we will cover what is data mining, history of data mining, the data mining process, data mining methodologies, summarizing, classification, association, clustering, trend analysis, data mining techniques, pros and cons of data mining. Let's begin. Data mining is a discovery driven software application process that provides insights into business data by finding hidden patterns and relationships in big or small data and inferring rules from them to predict future behavior. Key aspects: it's not just about numbers, it includes text and social media information from the web. The observed patterns and rules guide decision making. It's about discovering what you didn't know you were looking for. Think of data mining as exploring a mine. You don't know exactly what you will find, but you know there's value or somewhere. What is data mining? Applying statistical analysis techniques to data with the goal of determining unnoticed pattern or collecting categorized informations turns collected data into understandable structures. Important distinction is data mining is often used as a buzzword to describe processing large amount of data, but in its correct use, it relates to discovery of new things through observation. It's synonymous with knowledge discovery, finding insights that weren't previously known. Not every analysis of data is data mining. If you already know what you are looking for, that's confirmation, not discovery. Then, history of data mining. The term data mining was trademarked by HNC in 1990, but hands-on pattern extraction is centuries old. As long as statistical analysis has existed, the shift discoveries in computer science have shifted the field from hands-on to machine dependent. This allows for the use of data indexing and database system to handle data efficiently, even terabytes or petabytes. The application of statistical algorithm on a large scale, possibly in a distributed manner with less human error. This evolution has made data mining practical for businesses of all sizes, and data mining process typically follows these steps: business understanding, which defines objective and requirements, then data understanding, collect and explore initial data, then third, data preparation, clean, transform and format data, then fourth, modeling, apply data mining algorithms. Then fifth, evaluation, access result again business objective. Then sixth, deployment, put findings into practices. This is often called CRISP DM, which means cross industry standard process for data mining, the industry standard framework. Then data mining methodologies. There are five main data mining methodologies. Number one, summarization, finding a compact description of their data set or subset. Example, average customer age is 35 with standard deviation of 10. Then second, classification, learning a function that maps an item into one of a set of predefined classes. Examples, classifying loan application as approve or deny. Then third, association, identifying significant dependencies between data attributes. Example, customer who buy bread also buy butter 80% of the time. Then fourth, clustering, identifying groups of similar items. Unlike classification, the group are not predefined. Finally, trend analysis, which is time series data, which identifies pattern over time. Example, sales peak every December and trough in February. Each methodology serves a different analytical purposes. Then data mining techniques. Several techniques are used to implement these methodologies. Cluster analysis. Cluster analysis, the most common clustering techniques, neural network for complex pattern recognition. Third, online analytical processing OLAP for multidimensional data analysis. Then data visualization for exploring patterns visually. Two logic approaches are there. One is deduction, which concludes information that is logical outcome of information stored in the database. Example, all men are mortal. Socrates is a man, therefore Socrates is mortal. Then induction, deriving generalization information from database. Example, Socrates is mortal, Plato is mortal, therefore all men are mortal. Decision trees, tree-based classification and prediction. Second, rule induction, extracting if-then rules from data. These techniques are the tools of the data miner. Then pros and cons of data mining. Pros of data mining derives profitability and efficiency, helps identify opportunities and reduce waste. Second, can be applied to any type of data and business problem, versatile and widely applicable. Then third, can reveal hidden information, discovers insights you didn't know existed. Then cons of data mining. It is complex, requires specialized skill and knowledge. Second, results and benefits are not guaranteed. Discovery is uncertain by nature. It can be expensive. Software, hardware, and talent cost add up. Additional challenges are data quality issues can undermine results, privacy, and ethical concern with certain application. Results can be misinterpreted or misused. Data mining is powerful, but It's not magic. Success requires the right data, skills, and business context. Then, challenges in data mining. Beyond the general cons, specific challenges in data mining include data quality, incomplete, inconsistent, or noisy data led to unreliable patterns. Second, scalability. Algorithm must be handle massive data sets efficiently. Third, interpretability. Complex models may be accurate but hard to explain. Fourth, privacy and security. Mining personal data raises ethical and legal concern. Then, changing data patterns that were true yesterday may not be true today. Then, skill gap. Shortage of qualified data mining practitioners. Organizations that succeed with data mining address these challenges proactively investing in data quality, talent, and governance. And that brings us to the end of Unit 4, Predictive Analytics and Data Mining across four parts. We have covered Part 1, Unit Introduction to Predictive Analytics Methods, Evaluation, and Application. Part 2, Logic driven and data driven models, including clustering, time series, and neural network. Then, Part 3, Regression Analysis, Classification Models, and the advantages and limitation of predictive models. Part 4, Data Mining, its history, process, methodology, techniques, and pros and cons. Now you have a comprehensive understanding of how organization use historical data to predict future outcome, a powerful capability in today's data-driven world. In Unit 5, we will explore optimization and prescriptive analytics, telling us not just what will happen, but what we should do about it. If you found this series helpful, please like, share, and subscribe. Leave your questions in the comment. Thank you for learning with me.